Hi everyone. Excuse me. Sorry about that. So last time we learned about how to name ionic compounds, and I also showed you some common polyatomic ions. Okay, so it's a polyatom, and at the end you have a charge for the ion. These are some of the common polyatomic ions, and we will see some examples as to how we can name an ionic compound when it contains a polyatomic ion. Okay, let's do with some problems. Give the systematic name for each formula or the formula for each name for the following compounds. We are given the formula FeClO4 2. Okay, now we need to give the name for this one. Now we have metal as Fe. Remember, Fe, which is iron, is a transition element. So it's not the main group element. Because of that, it can have more than one charge. Now we need to figure out what is the charge of iron in FeClO4 in order to write the name. Okay, so we can use the same way that we used earlier. This is FeClO4 and this is the polyatomic ion, and we have two next to the parenthesis. So to find out the charge, we can do the back crisscross. So the charge goes to the 2 subscript goes to the charge of iron, and when you don't have anything next to iron, that means it is 1, and 1 goes next to perchlorate, this guy over there. So now we can figure out the charges. So then the iron need to be 2 and ClO4 need to be 1. And always we write in a formula cation first. So this is plus and this is minus. So these are the two ions. By doing this, we can find out the charge of the ion. So then it has to be ion 2. Remember, you have to write in parentheses if it is a transition element or it has more than one oxidation number, ion 2. And then you need to figure out what is the name of ClO4 minus 1. So you can refer to the chart. So you go here. So ClO4 minus, which is written in red, is perchlorate. So then you can write the name ion 2 perchlorate. So that is the name of FeClO4 parenthesis 2. So always if you have more than one polyatomic ion, you have to put the parenthesis and say how many. If you have only one polyatomic ion, then you don't have to put the parenthesis. Okay. And B is sodium sulfite, Fite. And we need to know how to write the formula for this one. Now sodium, you go to your periodic table and locate sodium in your periodic table and find out the charge of sodium. Sodium is in group 1, so group 1 normally makes plus 1 charge, right? So sodium makes plus 1 charge. Sodium plus 1. And then you need to refer to the polyatomic ion table to find out what is sulfite, Fite. It's not Fide, sulfide. IDE is the element you directly get from the periodic table as a nonmetal, but when it is sulfide, you can see here sulfide is this one right there. It's a polyatomic ion, SO3 2 minus, sulfite. Okay, so then you have to refer to that, SO3 2 minus. So you go over here and then you write that's going to be SO3 2 minus is sulfide. Remember sulfide, SULFIDE, sulfide is minus 2 ending in ide. That is directly coming from the periodic table, but this is sulfide, ITE, coming as a polyatomic ion, sodium sulfide. Now this is the two ions, sodium sulfide. Now we need to put this together to find out the formula. So how do you write the formula? So again, you're going to crisscross the charges. One goes here, two goes right there. So then sodium sulfide would be Na2SO3. And remember, you don't have to put the parentheses since it's going to be only one sulfide group. So that's the formula for sodium sulfide. Okay, and then the next one is barium and then with another polyatomic ion. Now for barium, so you find barium in the periodic table. If you go and refer the periodic table, you will see barium is in group 2 and group 2 makes 2 plus charge. And then you're going to go to your polyatomic ion table and find out OH. So OH right there, that is hydroxide. Okay, hydroxide is OH. OH minus 1. So then you can go ahead and write OH minus 1. So those are the two ions, right? And then when you crisscross, the formula is already given. I'm just showing you how the formula came. Okay, so there are two hydroxide because 2 goes here, 1 comes there. So barium hydroxide formula would be BaOH twice. So that's what given here. Now barium is a main group element, and because of that you don't have to write the name and the charge in the parentheses. So you can just write barium hydroxide. And then when you have 8 water molecules like that, normally we represent water as hydrate and then you say the number of water molecules. For 8 it's going to be octa. So I would say barium hydroxide octahydrate. Barium hydroxide octa. If it is 6, it would be hexahydrate, like that. So the name for that going to be barium hydroxide octahydrate. Okay. And explain what is wrong with the name or formula at the end of each statement and correct it. Now this one, first one, barium, this thing is called barium diacetate. And what's wrong with this is, so this is ionic compound because you have barium and this is the acetate group. We don't use the prefixes as di for an ionic compound. So it has to be written as barium acetate. Okay, that is what's wrong. You don't call di for the ionic compounds. And then sodium sulfide has the formula Na2SO3. Sodium sulfide, remember IDE comes if you get a nonmetal directly from the periodic table. For example, Cl minus 1 would be chloride, S2 minus would be sulfide, IDE, but you have written here is SO3. SO3 is a polyatomic ion which is sulfite. So sodium sulfide would be Na2S because sulfur is minus 2, sodium plus 1. When you crisscross the charges, it should be Na2S. Sodium sulfide would be Na2S. Okay, and what's written here is sodium. This one is sodium sulfide, SO3. Even for sodium sulfide, when you write it, you do not write the parentheses like this. You don't put parentheses. Okay, so that makes two things wrong in it. One thing is you don't write parentheses in sodium, and what is given here is sodium sulfite, not sodium sulfide. Okay, so sodium sulfide is this one. Sodium sulfide I just showed you is this sodium sulfide IDE, and this is sodium sulfide. And then see, iron 2 sulfate has the formula Fe2SO4 thrice. iron 2 sulfate. Now it's given as iron 2, meaning iron oxidation number +2. And sulfate, let's go to the polyatomic ion charges and see what is sulfate look like. Sulfate, hey, sulfate SO4 2 minus. Sulfate is SO4 -2, so charge of the sulfate is -2. So if you put together that Fe2 SO4 2 minus sulfate, so when you crisscross the charges, it would be Fe2 SO4 2. But in an ionic compound, if you have the same subscripts, you can divide it by a common factor and then it would become 1-to-1 ratio. So basically it would become FeSO4. Iron 2 sulfate is FeSO4. What's written in this one here is iron 3 sulfate. Do you see that? That one is iron 3 sulfate. This one that is written here, iron 3 sulfate, because it is Fe2 SO4 3. So if you crisscross the charges, 2 goes there and 3 comes there. That means iron is +3 and sulfate -2. What's written here is iron 3 sulfate and this is iron 2 sulfate. Okay, I hope you got it. Okay, so the next one, cesium carbonate has the formula CS2CO3. Now cesium, if you go to periodic table, you will know cesium is in group 1 and make +1 charge. And if you refer to the polyatomic ion charge, carbonate is CO3 and it carries -2 charge. And then if you write the formula, you can crisscross, 1 goes there, 2 goes here, that would make it cesium2CO3, 1. But normally if you have just 1, you don't write 1. And then even if you have just one polyatomic ion, you don't put parentheses. So here what's wrong is that you should not put any parentheses. So it should be written as just CS2CO3 without any parentheses. Okay. All right. So these are the answers. Okay, so let's stop here and then we'll go to the oxyanion nomenclature in the next session.